Okay, so there are some questions for tomorrow's test on how to solve a problem like this, so I'll just quickly run through an example here. When solid sodium hydroxide is dissolved into water, forming aqueous sodium ions and hydroxide ions, 445 kilojoules per mole of heat energy is released. So, first question says, write a balanced thermochemical equation for this process. So, basically we have sodium hydroxide, okay? It's dissolved in water. We don't even have to include the water. It happens in water, but we don't have to actually show the water to form sodium ions and hydroxide ions. And it releases energy, so we can look at this as a delta H is equal to negative 445 kilojoules per mole. So that's the first step. All right, then part B, how much heat in kilojoules is released when 50 grams of sodium hydroxide is dissolved in water? So, this 445 kilojoules is per mole, and we have grams, so we need to go from grams to moles, so we do 50 grams of NaOH, and then we need to convert it to moles, so we say 1 mole. Look up the masses of sodium, 1 oxygen and 1 hydrogen. That comes to 40, so it's 40 grams per 1 mole for NaOH. Grams cancel out, now we're in moles. And then the last thing is just looking at the ratio, right? 1 mole of NaOH, when dissolved, produces 445 kilojoules of energy. So, we're just taking 50, dividing it by 40, and multiplying by 445. And that value is going to come out to be approximately 500 and, 56.75, something like that, kilojoules of energy. So it's just something as that. So what you have to do is when you're given a heat energy from a reaction, that's always going to be in moles of reaction. Okay, in this case, there's only 1 NaOH, so it's just a 1-to-1 ratio. And then lastly, we convert from grams to moles, and then we can convert from moles to kilojoules. And that is how we solve that type of problem. Good luck tomorrow on the test.